Okay, so this is 3, 3 completing the square. Example 1, you can go straight to factoring the left side of your equation. So this is going to factor to the quantity x minus 8 squared equals 100. Once we have x minus 8 grouped, we can take the square root of both sides. Anytime you take the square root of a number, you need the plus or minus. So the left side is going to simplify to x minus 8, and the right side is going to simplify to plus or minus 10. After that, we just have to get x by itself by adding 8 to both sides, always in front of your plus minus. So x is going to equal 8 plus or minus 10. So 8 plus 10, which is 18, and 8 minus 10, which would give you negative 2. So these are your two solutions of x that are going to make this equation true. So the next one's really similar. Again, go straight to factoring. So this would be x plus 15 squared equals 121. And then we can square root both sides. We need the plus or minus with our number. So the left side is going to simplify to x plus 15 equals plus or minus 11. And again, we have to solve for x, so subtract 15 from both sides. And that's always going to be in front of your plus or minus symbol. So we have negative 15 plus or minus 11. So two solutions, negative 15 plus 11, which is negative 4, and negative 15 minus 11, which is negative 26. And that's going to be how you solve if your left side is a perfect square trinomial. I'm going to leave these ones for you to do and jump right into example 2. So the value of c that makes x squared plus 14x plus c a perfect square trinomial. Remember, the coefficient of the x squared term is our a value. The coefficient of the x term is our b value, and then our c value. So to figure this out is always b divided by 2 squared. So in this case, b is 14. So we would take 14 and cut it in half, which is 7. And then square that, which would give us 49. So c is 49. And that's going to give us x squared plus 14x plus 49, which then would factor into simply x plus 7 squared. So notice c is b divided by 2 quantity squared. And then when we write our perfect square trinomial, our constant is just b divided by 2. And then again, similar process in this one. So we take 40 divided by 2 and square it. So that's 20 squared, which would be 400. So c is 400, which means we have x squared plus 40x plus 400, and that makes this simply x plus 20 squared. And again, this number is b divided by 2 squared. It's always going to be positive because when you square anything, it makes it positive. And then in our perfect square, in our binomial squared, that's just b divided by 2. So again, I'll leave you the monitoring progress questions to fill out then for completing the square. Okay, the last process then from this section is actually completing the square if you're not set up. So if we look at the left side here, we don't have a perfect square trinomial, but since we have an equation, we can make it into a perfect square trinomial. The first thing that we have to do is group our variable terms on one side and our constant on the other. So we take that 7 over to the other side, which would give us x squared minus 10x, and I'm going to leave space and make that equal to negative 7. So this is where we're completing the square. So we have to add something to both sides, which that something happens to be b divided by 2 squared, in order to make our left side a perfect square trinomial, to set them up like example 1. So in this case, we take negative 10 and divide it by 2, which is 5, and then square that, and we get 25. And again, to keep this equation balanced, whatever we do to one side, we have to do to the other. And then it's just like example 1. So the left side is going to factor to x minus 5 squared. And then negative 7 plus 25 equals positive 18. And then we can square root both sides. And when we take the square root of a number, we need plus or minus. So the left side is going to simplify to x minus 5 equals positive negative square root of 18. And then we have to add 5 to both sides. Again, always in front of the plus or minus. So x is going to equal 5 plus or minus the square root of 18. We can't combine these because 5 is not underneath the square root and 18 is. But we can simplify the square root of 18. So 18 is 9 times 2. And 9 is a perfect square. So if we take the square root of 9, that's 3. And then we still have the square root of 2 left over underneath. So final answer for this one, x equals 5 plus or minus 3 times the square root of 2. So if we wanted decimal approximations, we could check out what 5 plus 3 square roots of 2 is in order to approximate the x-intercept. And we could also check out what 5 minus 3 square roots of 2 is to figure out what that decimal is going to be. So similar thing going on here. We need our variable terms on one side, and we need to get our constant then on the other side. So we have to subtract 5 from both sides, which gives us x squared minus 18x. And again, leave space in order to complete the square. And then that's going to equal, in this case, we have negative 5. And we are going to add that to whatever we add to the left side. So again, to figure that out, what we're going to add to both sides, it's b divided by 2 squared. So negative 18 divided by 2 would be negative 9, and square that and we get 81. So the left side is going to factor to x minus 9 squared. And that's going to equal 76. Again, we need the plus or minus. Left side simplifies to just x minus 9. This is actually 4 times 19. That would give you 76. 4 is a perfect square, so that's going to give us 2 times the square root of 19. And then last but not least, to finish this one off, we have to add 9 to both sides. So we end up with x equals 9 plus or minus 2 square roots of 19. And again, if we wanted decimal approximations, we could do 9 plus 2 square roots of 19 to figure out what that equals. And then 9 minus 2 square roots of 19, and that'll give us a decimal approximation for our x-intercept. Example 4, so sometimes you'll have this coefficient in front. That's the big difference with these ones. And again, remember, since we have equations, as long as whatever we do to one side we do to the other, then it's going to keep it balanced. So we can start by getting rid of this coefficient by dividing everything on both sides by 3. So it's going to give us x squared plus 12x, oops, not 12x, 12 divided by 3. So plus 4x plus 5 equals 0. And then same process as the last example. So get negative 5 over to the other side. And we have x squared plus 4x plus something equals negative 5 plus whatever that something is. So to figure out what goes inside of the box, we have 4 divided by 2 is 2, squared is 4. So we have x plus 2 squared equals negative 1. So because we have a negative for our constant, we're going to have complex solutions. So square root both sides. This would give us x plus 2 equals plus or minus. The square root of negative 1 is just simply I, or 1i. And then we have to still subtract 2 from both sides in front of the plus minus. So x is going to equal negative 2 plus or minus I. And again, if we wanted to look at each one individually, we'd have negative 2 plus I as one root, and negative 2 minus I as our other root. In the next example, again, we have to get rid of that coefficient of 2. So we're going to start by dividing both sides by 2, because as long as you do the same thing to both sides, it keeps our equation balanced. So we have x squared minus 10x plus 30 equals 0. And then again, get our constant to the other side. So we have x squared minus 10x plus something equals negative 30 plus that same something that we added to the other side. In this case, negative 10 divided by 2 is 5, and then square that, and we get 25. So the left side is going to factor to x minus 5 squared, and the right side is going to simplify to negative 5. Again, because we have a negative number, when we take the square root of that, we're going to end up with a complex solution. So we square root both sides, add the plus or minus in there, so x minus 5 equals plus or minus. To make this positive, we just change this to I times the square root of 5. And then we can add 5 to both sides, always in front of your plus minus operator. So x equals 5 plus or minus I times the square root of 5. So one root is 5 plus I times the square root of 5, and the other is 5 minus I times the square root of 5. And again, you have some monitoring progress questions here. On the last two, make sure you distribute the 6x through and the 2x through, and you're going to end up with problems that look like example 4 and then the tutorial extra example. Okay, so that's completing the square. That's the whole process. 3/4 is the quadratic formula. So it's another way to solve quadratic equations, but it's a completely different process. So mathematicians figured this out. If our quadratic is written in standard form, then this is how these different coefficients and constants behave. And that's going to give us our 2 roots or 1 root for our quadratic equation. So most important thing is we need the quadratic formula. So it's the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So with this, the most important thing is that you recall your order of operations. So we have to take care of this b squared first. Anytime you square a number, it's going to make it positive. Then we're going to go ahead and figure out what ends up happening under this grouping symbol, this square root. And then we're going to simplify everything else that we can then at the end of our equation. So in order to solve using the quadratic formula, our equation has to be equal to 0. So we have to bring this 5 over, which would give us x squared plus 3x minus 5 equals 0, which means that a is 1 because it's our coefficient here. B is 3 because it's our coefficient of our x term, and then C is negative 5. So we're going to plug these numbers into the quadratic formula and figure out what our two roots are. So the opposite of B is going to be negative 3. Plus or minus is a part of our formula. Then we're going to have B squared, so that's 3 squared, minus 4, part of our formula, times our A value, which is 1, times our C value, which is negative 5. And this entire thing is going to be over 2 times our A value. Again, 2 is part of the formula, and then our A value is 1. And all we have to do is clean this up then. So 3 squared is 9. And then we're going to have 9 minus negative 20. So it's going to be 9 plus 20. So x would equal negative 3 plus or minus the square root of 29, all divided by 2. And if we want to split this up, we could say this is negative 3 halves, or negative 1.5, plus or minus the square root of 29 divided by 2. So either one of these answers is acceptable. It gives you both of your solutions. And we could plug this into a calculator or into Desmos to figure out what these decimal approximations of our roots are going to be. So next one, same process. Start by bringing your constant to the other side because our equation has to be set equal to 0. So we have 3x squared plus 4x minus 10 equals 0. And we can go right into our quadratic equation. So it's the opposite of our b value, plus or minus the square root, of b squared minus 4 times our a value times our c value, all divided by 2 times our a value. So if we take care of our a goes there, and a goes there. Our c value is negative 10. There's only one place to plug that into. And then our b value is 4. So we have the opposite of 4, and then we have 4 squared underneath our square root. So cleaning this up a little bit, we end up with x equals negative 4 plus minus, I guess I didn't need that long of a line. The square root of, so 4 squared is 16. And then we're subtracting a negative 120, which would give us 136. 12 times 10, yeah, so 120, which would give us the square root of 136. And we're dividing that by 6. And this we can clean up and simplify a little bit. So the square root of 136, well, this is going to be 4 times 34. And 34 is just 17 times 2, so that's not going to help us out. But that's going to give us negative 4, 6. And I'm going to split this up right here. This is why it's a good idea sometimes to simplify. So this is going to give us 2 times the square root of 34. All divided by 6. And then we can just simplify these fractions. You can only simplify numbers that are outside of a radical with numbers that are outside of a radical. So you can't simplify 34 and 6. You can only simplify the 2 6. So x would equal negative 2/3 plus or minus the square root of 34 divided by 6. And again, we could, that should be a 3. because 2/6 is 1/3. And we could figure out what these decimal approximations are and relate them to our graphs. So in both of these, for example 1, we got real answers. You can see we didn't end up with the square root of a negative. And we got 2 real answers, negative 2/3 plus the square root of 34 over 3 and negative 2/3 minus the square root of 34 over 3. Those will give you decimal approximations. So there's the monitoring progress questions 1 through 3. For all 3 of them, you should get real solutions, 2 real solutions. Okay, so looking at these next examples, we need to clean it up a little bit before we plug it into the quadratic formula. So we can subtract 12x from both sides first, and we can also add 4 to both sides first in order to set this equation equal to 0. So we would have 25x squared minus 20x plus 4 equals 0. Again, we're going right into the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times our a value times our c value, all divided by 2 times our a value. So the opposite of b in this case is positive 20. And then we have plus or minus the square root of negative 20 squared, which is going to give us, again, a positive value. Minus 4 times our a value, which is 25, times our c value, which is 4. And then all divided by 2 times our a value, which is 25. So something interesting happens when we simplify this. So negative 20 squared is positive 400. Again, this number should always be positive. When you square a negative number, it makes it a positive number. And then 4 times 25 times 4 is also 400. So when we subtract this, we end up with 0 underneath our radical, and the square root of 0 is just 0. So we can forget about adding and subtracting 0, and we end up with x equals 20/50, which we can simplify to 2/5. So in this case, we only have one real solution. And that would occur at x equals 2/5. So similar with the next one. Again, we should get one real solution. They're kind of grouped that way here. So to set this equal to 0, we have to add 13x to both sides. And we have to add 16. So these are going to cancel. And we have 4x squared plus 16x plus 16 equals 0. And again, right into our quadratic formula. So x is going to equal the opposite of b plus or minus the square root of b squared minus 4 times our a value times our c value, all divided by 2 times our a value. So the opposite of b in this case is negative 16. And then we have 16 squared minus 4 times 4 times 16. And then all over 2 times 4. And again, when we square 16, we get 256. And we're subtracting that 16 times 16, which is also 256. So that's going to equal 0, which is the square root of 0, which is just 0. So x is going to equal negative 16 eighths. Negative 16 divided by 8 is just negative 2. And again, we end up with one real solution. So the first example, we had 2 real solutions. The second one, we had 1 real solution. And then in our third one, we're actually going to have 2 imaginary solutions. So set equal to 0 to start. So we have negative x squared plus 4x minus 13 equals 0. And we can jump right into the quadratic equation. So the opposite of b would be negative 4, and then we have plus or minus 4 squared minus 4 times our a value, which is negative 1, times our c value, which is negative 13, and then all over 2 times negative 1. So 4 squared is 16, and then 4 times 13 is 52. So 16 minus 52 is going to give us negative 36. And that's underneath the radical. So this is where our imaginary solution comes in. So simplifying that, we would have negative 4 plus or minus the square root. The square root of negative 36 is 6i. So plus or minus 6i all over 2 times negative 1, which is negative 2. And this we can simplify. Negative 4 divided by negative 2 is going to give us a positive 2. And then 6 divided by 2 is negative 3, but it's kind of taken care of in the plus minus. So that's going to give us just simply 3i. So these are our two imaginary solutions. We have 2 plus 3i as one of our solutions, and then 2 minus 3i as our other complex solution. And again, these ones give us two complex solutions. And then same thing, last one that we'll go through. So bring that negative 1 over. We have 5x squared plus 2x plus 1 equals 0. And we can jump right into our quadratic formula. So we have the opposite of b plus minus square root b squared minus 4ac all over 2a. So the opposite of b is going to give us negative 2. And then we have 2 squared minus 4 times our a value is 5 times our c value is 1. Just slide this down. So figuring out our square root, 2 squared is 4. And then 4 times 5 is 20. So we have the square root of 4 minus 20, which is the square root of negative 16. The square root of negative 16 is 4i. And that's all over 2 times our a value, which is 5. So we have x is equal to negative 2 tenths plus or minus 4i tenths. And then we can simplify both fractions, negative 1/5 plus or minus 2/5 I. And that's going to give you your two complex solutions, just like the last equation. So 3 different types of answers, 2 complex solutions, 1 real solution, or 2 real solutions, and that is using the quadratic formula. So try them, monitoring progress 4 to 6.